Hello and welcome everyone to another session in the DataHour series. We are thrilled to be here with you this evening for a session full of action-packed learning. I'm Dheeraj, part of data science team at Analytics Vidhya, and I will be the moderator for this session. And guys, for those who have joined us for the first time, let me give a brief introduction to the DataHour sessions. The DataHour is a series of webinars conducted by Analytics Vidhya and led by top industry experts. It is a fun way to understand the concepts of data science from the leading players in the data tech domain. And as the name suggests, it's 1 hour dedicated to data. And we are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. Now, on to our session today, which is 5 things you should know about Azure SQL. Uh, Azure SQL offers an incredible amount of features that helps modern developers to create cloud-borne solutions that are scalable, fast, flexible, and secure. It has evolved a lot in the last years, and many of the new features may have gone unnoticed to a developer that is already busy following evolutions of the never-ending amount of frameworks. So guys, in this data, we have Muazma with us. She will go over the top features that every developer must know, which can be used as they offer a unique way to make you more efficient and productive. And I hope you are excited to attend this data with us. So before we kick things off, I would like to hand it over to our speaker and a quick recap of the housekeeping items. And guys, don't worry, we are recording this session and we will make the recording available in a few days on our YouTube channel. And guys, please feel free to use the Q&A section for asking any questions you might have during the session. Make this webinar more interactive and we will do our best to answer them as the data progresses or towards the end. And also, we will share a poll about the feedback of the session towards the end, which I request you to all kindly fill up. Now, on to our speaker in the session of data, we have Muazma with us. She is a principal PM manager at Microsoft Azure SQL database, where she enables customers to deploy the most demanding data workloads on Azure. She has been a data engineer, architect, and tech speaker working on several big data, cloud computing, and AI technologies. She is a LinkedIn learning instructor with her course Breaking Bias in Tech, and her ML research software is used in EKG machines all around the world, and she is an advocate of diversity, equity, and inclusion. Now over to you, Muazma. The virtual stage is all yours.
Thank you everyone for joining. Let me start sharing my screen. So if the moderator, you can give me access to share screen, I can get started.
Yeah, 1 second. Now try.
Yeah, I am going to start it now.
Yes.
Okay. Hi, everyone. Thank you for joining. Good evening, good morning, good night, depending on wherever you're joining from. As I was introduced, my name is Muazma. I am a principal PM manager in Azure SQL database team working at Microsoft. I've been in the tech space for over 15 years now, primarily in the data and AI space, and have, fun fact, I've lived and worked in 5 different countries and 3 different continents. I'm really excited to share with you all today this deck and this presentation, which talks about 5 things you should know about Azure SQL database. At any point in time, if you have any questions in this session, please feel free to put them in the Q&A feature. I will spend last 5 to 10 minutes to take those questions and answer as much as I can. If I'm not able to get to those questions today, I would follow up, and you're free to connect with me afterwards as well on my LinkedIn or Twitter as well. With that, let me start sharing why I'm talking to you all about Azure SQL database. This is just a little bit more information about me. One thing that I'm really passionate about is sharing knowledge. And the picture on the top left is actually the very first time I did public speaking. I don't know if you can see the date. It's from a very old camera. It's 2006. So it's been a while that I've been doing this and sharing a lot of my work with different folks. In terms of why I am talking about this topic and why Azure SQL database, it is one of the oldest database out there. A lot of folks, as they have started to work on data science today, or they have started to look at data solutions, you might have not noticed all the different features that are already available there. And today in this session, the goal of this session is to give you an overview of what you should know, at least as a developer, to take advantage of Azure SQL database, and also the capabilities of Azure SQL in general, not just in the cloud, but also what are the other things you can do with Azure SQL. I will also give you references of different things that you can go to and learn more. There are several samples available that you can go and today try out and build your own applications if you want to. And I will also try to kickstart some of the conversations around how you can build modern applications in cloud-born applications using Azure SQL products that are out there. There are also some common questions that are here because I've been working with several customers over the years, with several developers. A lot of folks ask some of these questions to me, and I'm going to try to address some of those questions as well, and some of the common myths that folks have about a database system as well. In the end, I will go over the Q&A. Again, if there are any questions throughout this session, please put them in the Q&A feature, and I would like to get to them towards the last 5 to 10 minutes of this session. So I wanted to start with taking back to kind of a history, a trip down the history lane in 1989. I don't know if you guys can guess what are the different events that happened in 1989. Some of you might not have been born by then, but if you want to share, if anybody remembers any major events from 1989, please put them in the chat. I see somebody saying they're not able to see the screen. Is that the case with everyone?
No, it's fine.
Okay. I'm going to reshare just one more time just to be sure. Okay.
Yeah.
So 1989, what are all the things that actually happened in that year? One of the things, some of you are cricket fans, so Sachin Tendulkar actually made his debut in Test cricket that year, and he became the youngest man to score Test 50 at the age of 16 years. And we all have seen his career over the years, how it grew. The Simpsons was another show that was premiered that year, so that's another fun thing to know about that year. But why I'm talking about 1989 is Microsoft SQL Server, actually initial release date for that was April 24th, 1989. So it has been 33 plus years that this database has been out there, and all the features and all the capabilities that it brings is available for you to actually utilize. And over the years, you've seen many innovations in the product. We have seen many innovations as different waves of data architecture have come through, and the latest wave with the cloud computing and other platforms as well. Now, I want to focus about Azure SQL. And this I wanted, but before going into Azure SQL, I want to actually talk about the SQL overall. What are all the different products and capabilities that you can use today? So if you look at this picture, it's quite evident that no matter where you are, you can actually deploy Azure SQL or SQL in your environment. It can be on the edge, it can be on the cloud. So from left to right, if you look at this, there are plenty of options. If you have Linux, if you want to do in Kubernetes, you want to do in a cloud platform as a service, there are several options for you to actually go and take SQL from edge to cloud. So it does not limit you to deploy it in any of the platforms. And it is one of the few databases out there, and actually probably the only one, that is available in all the major clouds as well. So it's not just available in Microsoft Cloud, it's also available in AWS and Google and other cloud platforms. So because of the maturity of the product and the maturity of the features that enables you to build the cloud-born applications, it is used and deployed in many, many different ways. But I want to focus specifically on the Azure SQL side of things. There are several other things that you can do, and I'm going to take a deep dive into Azure SQL and tell you a lot more features about Azure SQL and what you can do with it. So in terms of Azure SQL, you have 3 different options to actually go and deploy. There is the infrastructure as a service option. So if you're familiar with cloud computing platform, that means that the cloud provider will be responsible for the for the infrastructure, and you will be actually deploying your own software on top of that. Platform as a service, there are two options to actually go and do. There is the managed instance option, and there is the Azure SQL database option. In terms of the managed instance, that particular offering is for lift and shift. So for example, if you already have a SQL server somewhere lying and you already have set of applications, you can actually do a lot of lift and shift on to cloud without changing a single line of code and actually move them into cloud. But if you want to, let's say, do migrate and eventually modernize your applications or build cloud-born applications, you can use Azure SQL Database because it has a lot of capabilities like Hyperscales, Elastic Pools, a lot of other features that I'm going to talk about today in this session. A lot of these features are cross-sectional as well, so they are available in all the other flavors of SQL as well because it's based on the same SQL Server engine. So that's the beauty of Azure SQL. In terms of service tiers, how you can actually go today and deploy Azure SQL Database. There are three high-level ways for you to deploy them. You can use a general purpose, which is most business workloads actually use that. It is a generic one. You can actually deploy any type of applications that requires a relational database or requires SQL or requires any kind of data storage for your transactional systems. You can also use business critical, which has a higher SLA, low latency. It has a lot of failure, high availability, disaster recovery, and all of that built into the system. And then the cloud-born applications for the things that you want to scale for future and to want to build today as a startup, as somebody starting your career, maybe you have an idea that you want to build an app with. Hyperscale is the way to go because it provides you a way to scale down, scale up, depending on what your workload is, and it can over time morph into something that you really want to do. I'm going to talk a lot more about several of these features in detail. And again, if there are any questions, please use the Q&A feature of this webinar, and I will get to that. As a developer, one of the common things or questions that is asked to me or I come across at different forums is how do I connect to databases? So if you go today to any modern database, you'll find several different native ways of connecting to that. Azure SQL is almost, as I said, is one of the oldest databases as well, based on the oldest engine. It today has several of those, right? So you can imagine any of the programming language or frameworks that you want to connect to, we have a driver for it. And again, the slide deck and everything will be shared afterward as well. All of these links you will be able to get to. If you want to take a screenshot of any of that, feel free to do that as well. But we have a lot of documentation. We have a lot of getting starting guides. We have a lot of great material for you to get started into any of these frameworks or languages or programming languages that you want to build your application with. And we have a lot of great community around that as well. Now, I want to get started about the topic of today's session. So far, I provided some very baseline information about what Azure SQL is. And then I kind of zoomed it into the Azure SQL cloud pieces and what does it mean. And gave you some introduction about how you can actually deploy, what are the different service tiers, and what are the different types of drivers that are available. So as the session title is to 5 things, talk about 5 things Azure SQL has for developers. The first one that a lot of folks don't know, and a lot of folks have probably a confusion around that as well, is Azure SQL readers are not block by writers. So the way the architecture is on the back end, everything that is the row versioning is to implement the isolation, which is the asset. If you look at the I part of that, that's the isolation. And as a database engine, this is what it's one of the great features that is enables is that the read is not blocked by write. So you can read as many kind of parallel reads that you want to from the same database that maybe one application or many applications might be writing to it. And I'm going to talk about a little bit in more detail about that in terms of scale, what it means for you for your application, some examples for customers as well, for you to understand how it is beneficial and why it is beneficial. Second thing that I want to share as a developer, this is something a lot of folks don't know about Azure SQL, that a lot of people think about SQL database as a relational database and think about typical data types like varchar, like integer, like all of the typical ones, but they don't know that Azure SQL actually is multi-model. You can actually store graph, you can store JSON support. So we have a very strong JSON support. You can actually store JSON data in it, and I'm going to share some examples here with you as well. And then you can also store geospatial type data in it, and it's based on an international standard that a lot of other databases are actually using, or other platforms such as Spark, if you're using that in your data workstream. And it also has geospatial indexes, so you can actually index the data which is stored as geospatial data. Now, what does it mean? So I'm going to talk a little bit about graph models. If in a typical graph theory, if you've come from computer science background, or if you've done some interview practice, this is one of the things that a lot of folks actually ask questions in interviews. What is a breadth first search, or how do you actually get from one data point to another data point? Why use a database to store graph data? A lot of customers have very interesting scenarios where they want to understand the connection between data. And to get to from one point to another point, they want to understand what is the shortest path. And that type of use cases are currently being served by specialized databases. And if you want to go to a specialized database, that means if you have to write an ETL job or something that has to take the data from this database into another place, you have to own the compute, you have to do this extra work to maintain those systems. Now, in Azure SQL, you can actually store your graph models as edge and node objects. If you go to this link, you can learn a lot more about what does it mean, how can you do it, and you can actually use things like match. You can also use a lot of other kind of functions and shortest path type analysis on your data. And this is just very high level architecture of how graph models actually work in Azure SQL. Now, why graph in Azure SQL? Thanks to the Azure SQL engine, graph support can be used along these existing technologies. So you don't have to move the data out. You don't have to deploy a specialized database to do that. You can actually use the engine itself where your data is being stored to be used for graph use cases. And this is an example of an interesting use case where using Hyperscale Gen 5 SKU, which is type of a compute, you can actually get to that many 50 billion likes and all of that unique users and songs. This is the database. You can actually go try it out yourself. You can see how fast you can get to your data, and then how fast you can do analysis on this kind of data as well. And you can bring your own data, try it out, and give us your feedback depending on what is your use case and how you will want to use the SQL data for graph use cases. One of the customers who's been using this, and this is an interesting case study. It is an energy company based out of Europe. And what they do is they actually use SQL to store a lot of the data. They actually moved to NoSQL at some point, and then they realized that trying to do a join on a NoSQL database, it's almost, it's really, really difficult to get the data in time for that. So in order for maintenance for any of their energy grids or any of the outages in their energy grids, they store data in SQL and then use graph to actually get to, if one of the, let's say, grid is down or there is a maintenance happening, they can find what's the shortest path and how can they get those users in that area energy from a nearby grid as well. So using graph data stored in Azure SQL, they can find the shortest path, they can find an alternate path to actually get to that data very fast. This is one of very interesting use cases that you can read it about on the link that's shared on the screen. Now, in terms of JSON, so I talked about the first feature, which is the read committed snapshots. The second feature I talked about multi-model, and then within multi-model I talked about graph, and then I'm talking about JSON at this point. So this is, again, a lot of folks don't know that JSON is currently heavily used in a lot of integration data points. When you want to store data coming in from your application or taking data out downstream to do some interesting things on top of that, JSON is a common data type that's used across. And a lot of folks don't know that you can store JSON data type in SQL databases. There's a great support for JSON already in Azure SQL. It's been there for years. You can actually store JSON data inside of SQL database as a column and as basically as a data type. And then there's a lot of support around that. For example, if you store JSON in SQL, you can use functions like isJSON. You can find JSON path exist, JSON object, JSON array, a lot of those functions. And we are continuously evolving and improving these functions and how they work as well. So this is something, again, you don't need to go to a NoSQL data stores. You don't need to actually go to another data store just for this capability to have kind of unstructured data to be stored in a relational database. You can do all of that inside of Azure SQL using JSON. So far I talked about two major features. One was read committed snapshots, and then secondly, the multi-model capabilities of Azure SQL. Talked about graph, talked about JSON. I don't have any slides on geospatial, but you can definitely look that up. We have a lot of great support about geospatial data in Azure SQL as well. The third thing that I want all of you to know about is column store. So this is, again, a lot of folks don't know, especially developers who are starting new, or you've been in industry for a long time, but have focused on a set of features in certain databases, have not kept up with what is the latest advancement in some of these databases as well. Column store is another way where folks actually have used Azure SQL database or Azure SQL in general to store data and then kind of retrieve the data for analytical queries. And the interesting part of that is column store is updatable as well. So just think about it. If you understand the architecture of how databases work, this is great. This is a great feature, and a lot of our customers actually use it when they have a mixed workload, when they want to store transactional data, but they want to do some analytical queries on top of that as well. And it's because of the Delta store on the back end. It's been available since 2016. So it's about 6 years or so. And one example of that, if you are aware about the TPCH benchmark, this is a common benchmark. A lot of databases actually look at the speed of it or look at the performance of a database. This is the 10 gigabyte query using business critical Gen 5 SKU in Azure SQL. And if you run that regularly without a column store, it will return the data in 55 seconds. If you do it with column store, any guesses, any number you think that the improvement would be in this case? $10. Somebody said 10. It's 4 seconds. So somebody said 5 seconds. It's really, really close. So that's the beauty of column store on top of a relational database or on top of a transactional kind of system, that you can actually use the combination of analytical type of queries on top of a database like Azure SQL. So this is a great feature as well. If you're not aware of, if you're not tried, not used, definitely think about that. And if you have a use case that has a combination of transactional as well as analytical data, this is a great feature to do. And it's very easy to set up and actually very easy to use as well. So talked about 3 features so far. I'm going to just repeat so you guys don't forget about that. The first one was read committed snapshots. Second one was multi-model, and within multi-model, we talked about graph, JSON, and geospatial capabilities. And the third feature I talked about is column store. Now, moving on to the fourth feature. And this is, again, a common question, I think, today in interview prep and all of those places where folks are learning SQL or understanding SQL. Some medium to hard questions actually include these window functions. If you're not aware of that, definitely look them up. This is a great way of manipulating data which is stored in rows and columns. You can do running totals, you can do moving average, growth ratios, a lot of that. I know for data science use cases, this is something very, very useful to understand a particular set of ranges and how you can do totals within that. You can do a lot of fancy stuff using window functions, and definitely look that up. You can also define ranking logic. I think this is one of my favorite interview questions that I ask in folks for SQL. And lag, lead, and all of these other ones allows you to go to previous and next rows as well, and then try different like cursor and loops like operation for a SQL data store. So windowing function is a great way to get to your data, to do different type of analysis on your data, and a lot of great functionality is available in Azure SQL for you to try out. And it's been available for a while as well. So definitely try it out, look at, store some data, try these window functions, and give us any feedback if you have for these. Fifth and the last feature here is that I wanted to share is no more passwords. This is another thing. So a lot of databases, and when you have complex applications, you don't want to be in business of storing passwords. And there are a lot of security issues that can happen over time if you are committing code to GitHub, or you have a particular kind of deployment pipeline, CI/CD, continuous integration, continuous deployment pipeline. You don't want to be in business of storing passwords. And this has been an issue in the database space for a long time, where we have admin, and then we have users several level, and every user has a password. Password is still the go-to way for a lot of people because they're comfortable with it. But with Microsoft, and specifically with Azure, you can use the Azure Identity and Managed Service Identity to actually go passwordless. What it means is you can actually, this is a code snippet. It's very simple to set up. There is a getting started guide on that as well, how you can use, and you can actually remove passwords end to end from your connection strings. And there are several different ways to actually use this and then make your applications and the database more secure. You have a single identity to get in. You actually can maintain that managed service identity across other services in Azure as well. For example, if you're using storage, you can use the same identity to get to that. You can have different levels of identity as well if you want to, and then actually get to that. So it's a great feature. Again, a lot of people don't know about it because they are familiar with passwords, and they actually go and just go ahead and create the database with the set of a lot of passwords as well. So definitely check this out if you've already not known about. If you already know about this, give us any feedback as well. So in the chat, out of the 5 features, just put a number out there. How many of those features were the ones you already knew about? Did you know about all 5? Did all 5 of them were new for you? Just put it in the chat so we can keep this session more interactive, and I can get feedback directly from you all as well that you're available. So yeah, somebody said all new. Another person said new to me, all new to me. 4. That's great. All new. Awesome. Then I think my job here is done. I shared a bunch of things that you did not know already about SQL database. Very useful. Thank you. So I actually lied. I am not going to talk about just 5 features. I actually have 4 features to talk about, and scenarios and questions from developer perspective, because I want to make sure that you as a developer building apps, starting new, or maybe in the industry for a long while as well, and you've used SQL databases at different places, different types of databases in the past as well. What I am hearing from the industry, and I am looking at what folks have used that to deploy different type of applications. Thank you for the kind words in the chat. Somebody said excellent knowledge. Thanks, informative, a very informative session. Thank you. So I want to talk about some of the other features. So I'm going to take a quick recap of what I've talked about so far. So I provided a little bit history. I talked about the different type of deployment options from edge to cloud, how you can actually take SQL to deploy in almost any platform out there. And I also mentioned that you can deploy it on any other cloud as well. So you don't have to do a lock-in with a particular vendor if you go this route. So that's just to level set everyone, that you understand that there are options for you to take your current deployment anywhere that you want. I talked about different types of drivers, and then I went into details about 5 features. So I talked about read committed snapshots. I talked about multi-model, and within multi-model, I talked about graph, JSON, and geospatial capabilities. I talked about 3rd feature, which is column store. Then I talked about windowing functions. And last but not least, I talked about going passwordless using Azure SQL capabilities. Now, a lot of the newer use cases, one of the new buzz in the industry is blockchain. A lot of people are thinking about blockchain as an area to go into. People are working on Web3. A lot of that is a buzz that a lot of folks are working. They're building startups around that. So in terms of databases, again, if you think fundamentally, databases are actually the reverse concept of blockchain, right? It's to store data at a single place versus blockchain is pretty distributed in that perspective. But how you can actually use a database to know a particular record and have an identity or a proof related to that. So for that capabilities, we introduced Ledger. So Ledger is a feature which is tamper-proof tables. That means that you can actually whatever goes in those tables, it's actually hashed, and there is a cryptographical kind of history around that as well. It's verifiable as well. So you can use data stored in SQL as a blockchain application as well. And again, go to this link and you will find a lot more information about how customers are actually deploying that. These tables in Ledger, these Ledger tables are updatable and or they could be append only, depending on what is your use case. But every time any update is happening or an append is happening, there is a record of who's doing it. There's a lot of auditing. There's a lot of evidence. So you can actually do a proper audit of your tables. So why we are thinking about this? So I'll tell you one use case of a customer where a customer had an app. That app was actually used in nursing homes. So people in old age go to nursing homes in certain countries, in certain places. And then there, in that, every time the nurses over there actually administer an medicine to the elderly in that nursing home, they actually put a record of what they administered. So you can imagine that record is really, really important, because the life and death of that person really depends on that data. Because if I accidentally update any record, I can harm the person who's coming after me as a nurse, taking the shift from me, and they can re-administer the medicine for some reason, and that person can have a lot of severe issues because of that. So this is an actual customer. Without taking the name of the customer, I'm just sharing a use case, how they're using Ledger tables to actually keep a record and audit, and then have tamper-proof tables to make sure every time the nurse goes in, they administer the medicine, they actually go and update that application. That application stores the data in the backend in the Azure SQL database, and then in the application, they're actually as a Ledger table. So you can actually go back and find out exactly who administered that last medicine as well. There is a history, there is a record, there is a lot of verification that you can do on top of it. So this is a great feature. It's a newer feature. A lot of folks don't know about it. This went into GA, general available recently as well. And if you have a use case like blockchain, you have a use case where you want to have a verifiable record of data, and you want to see this history, this is a great way to do that. And you can do a combination. So you can have a set of tables which are Ledger tables, and you can have other regular tables as well. So this is, again, you don't have to take a data out to a specialized database just to do this kind of workload or this kind of use case. Somebody asked in the chat, can you please share the PowerPoint? Yes, I will share it with the organizers, and we will be able to get that afterwards as well. The seventh thing I want to talk about, so we talked about five features, and then I talked about the Ledger, the Retry Logic. So as a system design person, again, I know a lot of folks prepare the system design interview questions or think about system design when they're designing their architecture. One of the things, or a nightmare for anyone who's on call, is when they get that something failed in their systems, and they get alarm at 2 a.m. or 1 a.m. or 5 a.m. that the system is failing. And when the system is failing, if you go and kind of do a root cause analysis, most of the time, some developer, somebody has forgotten to put in retry logic, because of whatever reason your database is down, or your firewall has some issues, or your network has some issues in the application itself. If you have not put a retry logic, your overall application will fail. The data will have no place to go if you've not put any kind of backup mechanism there. And then if you keep it running for a while, the end-to-end application will start failing, and a lot of people will be unhappy. So, so this is a common problem. So, as a Microsoft SQL Data Client library itself, so as part of that library itself, we have enabled this retry query logic. You can go into this and learn more about that. It's configurable. It is kind of the bottom line for you to actually make sure that you do that as part of your application and part of the design. This is a very important concept. If you have never done this, if never tried it, never thought about it, at some point your application is going to fail if you don't have it in place, either on the application side or on the code layer or of your basically architecture. So this is a great feature by default that you can use. There is a little bit of configuration you have to do. Definitely go try it out. And again, if there are any feedback, any questions, happy to answer those as well. Last feature that I want to talk about is now, let's say you have built a great app. You have actually used a bunch of these features. Now you're whatever you want to do, you're able to achieve that. How you can actually deploy that as a DevOps engineer or somebody who owns the infrastructure, deploying database objects outside of your DevOps cycle has been a norm in the industry for a long time. So there's usually a database administrator who actually goes and deploy your tables and indexes and all of that. And then the developers are owning the application code itself. But if you look at the industry trends, this is actually merging into one DevOps cycle where the developers now own a piece of the code which actually does the CI/CD pipelines. It also includes databases. I really want to emphasize that your database should stay with you in every step of this cycle. So in order to do that, we have actually provided some features. And one of them being Microsoft, we have some of these integrations with GitHub Actions. So if you're not use GitHub Actions, is a great way to actually go and deploy different things very fast, one click. You can actually do that for database projects now. And definitely take a look at Azure Data Studio SQL projects. And there are a lot of great videos. One of my colleagues, Drew, has been the person who owns a lot of this backend and how these features are enabled. There is a lot of great talks by him also, so I can share some of that later in the chat or as part of the material. If you are in the DevOps space or if you are a developer who owns this DevOps cycles, definitely check that out. So the concept of deploying this with GitHub Action, this emulator that we have as a Visual Studio Code extension is you don't need to connect to an actual database unless you need to commit anything. So you can do all of your development within your favorite IDE, in this case, Visual Studio. And within Visual Studio, you can actually create the database objects. You can actually try out different things. You can also do DDLs. Again, there's no real database yet. You can do all of that in your inner loop while you are on your machine or on your kind of server or VPN or whatever you work on. When you're ready only to commit the code is when you will need something to actually go and deploy. So basically it saves cost as well. This actually improves the developer productivity a lot. And again, this topic itself, we have a lot of talks just on this topic. So I'm not going to go into a lot of detail here, but if you have questions around that, feel free to ask those in the chat and I will get towards them in the last 5-10 minutes as well. And then finally, as I said, when you want to deploy that, you can actually do that as the last step as your outer loop. And part of your GitHub Actions, this is very simple and straightforward as well. So definitely try this out if you have not already, and if you have any use cases where you want to do end-to-end kind of deployments or DevOps type work for your database or applications. So I'm going to summarize the 5 things that you should know about Azure SQL. I talked about read committed snapshots. I talked about the multi-model, which includes JSON, Graph, Geospatial. Talked about column store. Talked about windowing functions. No more passwords. And then I talked about some extra things. It was not really 5, talked about 8 things. That includes Ledger, Retry, Logic, and CI/CD using GitHub Actions. So I'll take a pause here before going into some of the common questions that I get from developers. I will go into one question that I can see in the chat right here. That is about how will we know about transient errors and queries. So this is going to be part of your the application logic itself. In terms of the transient errors, if you can clarify in chat what you mean, if that's mostly because of any kind of retry logic or kind of anything that's not happening on the downstream where you want to store, again, having retry logic is going to save you from that. In terms of the SLAs, Azure SQL has really great SLAs that we support that make sure that everything that goes into, basically there's no data loss for that, right? So we do support these SLAs, and we maintain that SLAs as a number for our service as well. So we want to make sure that you don't have data loss, and then in order to make sure that your application is also foolproof, you need to have this kind of retry logic in the application layer to make sure the data gets to your database as soon as you want it to be. Okay, I will get to the Q&A part of it towards the end as well, and just talk about some of the common questions that I have seen over the years coming from different developers. So this is a fun one. This is what I think at some point in my career also I've evaluated different databases or different infrastructures or different options as data architecture, as a data architect, to see which one is the best database to store certain type of data or certain number of rows, so the volume of it. So question people ask, I have n number of rows, I have like millions of rows or maybe trillions of rows or billions of rows, I don't know. Is Azure SQL database a good choice for that? So I have an example here for you without taking the database name, without taking the showing you the actual that, but this is an actual query ran by a customer. This is on their system. This is actual user, so I'm not making this number up. This is a screenshot taken from their query. It's not a simple query as well. It's a query with a where clause. It's a query with an in statement there as well. You can see this query actually ran for about, the overall execution time is about 27 milliseconds. And again, it's not a simple query. It has a date between thing, and it also has an in. The result set actually return this many rows. So in the chat, could you just quickly tell me, what is this? Like, tell me in numbers, like, is it million, billion? Anyone has a guess how many rows are in this table or in this result set? $1 zillion, okay. 16 to 2 trillion, okay. Great, so it's 1.6 trillion rows. And some of you are very, very close. So it's 1.6 trillion rows. I don't want to do the math of how much of that data is in this table that the in clause is returning this one. But this is the amount of data where one customer is actually using it, and they're using very efficiently. They're storing this in this database. So I want to kind of burst this myth that for big volume kind of application, you can't do this. So customers have been doing this. Again, it comes down to how you architect it. What are the indexes? What are the different types of applications? How do you actually scale out all of those different concepts? But it's possible, and this is an example that I wanted to share. So to me, the question really should be what I'm doing as a use case, and can this database store that use case for not just today, but also in future? Can it scale to my future uses as well? It's not about number of rows anymore, because almost you can see this number, which is quite eye-opening that you can do this very effectively in SQL database. Now, another question a lot of people ask, a lot of developers have asked. So I want to scale without data movement. And this is again a thing of the past where you had to actually move data out to actually provide scale for that. So like a replica of something that you will have somewhere else for read use cases and then write use cases. Or you will have something like today your application is, let's say, selling something, and then there is a major event like Black Friday that happens in the US, for example. And you want to scale your application to kind of get to that workload on that Black Friday, but you don't want to pay it throughout the year. So how can you achieve that during that time only, right? So one of the things that we introduced in this Azure SQL is having Hyperscale. So Hyperscale is the whole, I showed you in one of the early slides, there is the whole service tier that you can actually go and deploy. You can using that tier, you can deploy read-only replicas up to 30. So you can, and they're the exact copy of your database. As soon as the data lands in your master or in your primary, your replica has the data available. As I mentioned, one of the capabilities that we have, you get read committed snapshots. So you are able to get that data very fast, and then you can scale as much as much as you can afford, basically, right? So in that case, what happens is, and this is an architecture on the back end, or just for you to understand, let's say you have a 4-week course or 4-week course primary, and then you can actually have that many replicas. And the beauty about these replicas is that they can be of different configurations. They can be 2-week course, they can be 16-week course. So you can have, let's say, a particular set of, let's say you have a data science department who wants to use this data as soon as it lands, and there are a lot more kind of read concurrent queries that are coming in from there. So for that particular one, you can have a 16-week core one, and for other ones, you can have 2-week course or something. People use this also for maintenance. They do this for a lot of other things. All of these replicas actually read the data from the same page servers, which is storage. So the way we re-architected this in cloud is we separated the compute and storage, and that's how you can actually get to that scale. So this is a common question: can I scale out? Yes, you can scale out. You can use read replicas. You can use Hyperscale to actually do that. One of the other questions. So either you're trying to save a cost, or you have a workload where it is a lot of different types of ups and downs in the time when you use the database. Can you pause and resume a database because you don't want to pay for the time when there's no activity, for example? So for that, yes, again, in the cloud, we have an option called serverless, where you can pay for use. When you are you pay based on your CPU cycles. You can set it up very easily as part of your application code as well, or as part of the database, depending on how you want to kind of maintain this. It's very cost effective, and if you have an intermittent workload where you have high kind of active and inactive periods, you can actually go ahead and do that. So this is an example of, let's say you have no activity between midnight to like 4 a.m. You can pause the database and then you can resume it and then start from that point onwards. When the database is paused, I do want to let you know that you will be charged for the storage still, because the data is still on storage. Storage is really, really cheap as compared to compute. So that's how this works. So definitely that's possible. A lot of customers we see actually use this. They have different types of workloads where they can pause and resume their database. So in summary, this is some of the common questions around scale that I get from developers, either the number of rows, either like talking about data movement, if you need data movement to move from one database as a primary to a read replica or something like that, is that possible or not? You can change the scale of your database without any migration of data. It's a function on the portal itself. It's a function on your CLI. You can do it very easily. You don't need to go actually to do that and move the data out for another set of users in your company or another folks that want to use that data. You can actually go serverless for auto scale with auto pause and resume. You can actually look at query bottlenecks that have that are causing you some problems. Multiple people try to have similar queries on that. This is a common problem. I know we all have done select stars on huge tables, and we have all been bogged down with from DBAs and other folks who are responsible for maintaining our databases. We've got those emails also in the past, and then the way to go is you separate the read-onlys, where your write is not bothered or not affected by the read load. And then if you have kind of sharding issues or things like that you want to do, very, very interesting use cases I've seen, customers have actually gone into using machine learning to decide which read replica to go to as well. So there are a lot of interesting ways to actually use this. There's like limitless options with Hyperscale, and then especially with named replicas. You can name your replica and then use that replica for that particular purpose only. So you can imagine there are many, many use cases. Let's say you have an application, there is a downstream vendor who wants to get that data. You can name a particular replica just for that vendor. So a lot of people actually maintain the databases in this way, where there's a clear separation of who is using what, and then sometimes they can charge folks for that as well, for that particular case. So definitely check this link out, know a little bit more about Scale. I will leave you with this. This is something, as I lead the developer division in this team, a lot of folks talk about developers. Traditionally, a lot of people think that DBAs are the only ones who need to know about databases. That's not the case anymore. The industry trends are changing. Application code folks, people who are developing applications as a full stack developer are trying to or getting more understanding of databases as well. And Azure SQL is for every developer. So if you're developing code, no matter what language, what framework, we have drivers for almost everything. We have a great community that supports that. And then you can use a lot of these built-in services, a lot of great capabilities like Json and geospatial and a few others to actually do that. And then it can enable database across multiple platforms. And don't just take it by my word. Definitely, there are a lot of customers that have used this. The BKW I already talked about their graph use case. There are a bunch of others at Microsoft internally as well. Microsoft Dynamics 365 actually uses SQL on the backend for their product. So if you know about Microsoft Dynamics, on the backend, it's actually using SQL. And a bunch of other ones as well. There are a lot of customers. There are at this point 10 million plus active databases that we have for this service, and the number is growing by the day. So as I said, being in the industry a long time, having a core engine that works and that can do a lot of great things. There are a lot of great innovations that are happening on top of that for the cloud side of things, and overall taking it from edge to cloud, going where the developers are and making sure that we get to those. This talk was inspired by one of my colleagues, Davide Mori. If you don't know him, definitely go follow him. He has a great blog about this as well. You can definitely read up on that. I really like the way he sketches. So that's the one which we say Azure SQL batteries included, which means that it comes loaded with a lot of things that you can do today. I will get to the resources slide here, so you can take a snapshot of it. And I think I have a few more minutes to take some questions. So let me go to the Q&A and get to that.
Sorry to interrupt. Before we proceed to answer your questions, I would like to request the attendees to please fill in the poll about feedback, as it helps us to conduct more sessions. Yeah, now you can continue.
Thank you. Yeah, feedback is really important. Please provide any feedback for this session. So I'm going to do Q&A right now to just kind of see. The first question I see here is, can you demonstrate cloud native apps using microservices to do that? Yes. So if you go to the documentation page and just search microservices, that there is a great demo and some examples over there. In the slide that I'm showing right now, the second link on the top, this one, the Azure Stack app, full stack app, it's a serverless app. You can actually, this is a learn module, it's free to do. You can go today and deploy that app end to end with Azure SQL. you get like 4 hours of time on Azure's Microsoft Learn. So definitely go try it out. This is a great Learn module, Learn basic learning path, where you can deploy a full stack app using Azure SQL. It also talks about serverless components and also has microservices components, like some of that, including Azure Functions and some other components. So definitely try this one out. We actually use this as a workshop at different places, and a lot of developers actually love that. So yeah, there is a lot of ways to do that, and maybe in one of the future talks we can go into more detail about microservices applications and how you can do that as a full stack developer. But we have a lot of samples on that. Yeah, so the question is, I'm new to data science. Is a good experience with SQL. So query, is Azure SQL different from SQL Management Studio? What is different is what need. Okay, yeah. For data science use cases and other use cases, no, it's not. So as I said, Azure SQL is using the core SQL Server engine. So it's built on the same engine. It has the same capabilities that the SQL Server provides. So it's not separate. The difference in Azure SQL is the cloud component. So all the stuff that I talked about scale. So if you had a SQL Server or SQL on-prem or anything like that, you had to actually buy physical servers to actually to scale that, right? In terms of Azure SQL, you can go today, create an account. I have the link on here for you to try it for free. Where if you're a student, there is Azure for Students as well that you can go try it out. You can try out the scale, and then with a few click of buttons, you can actually scale your applications to anything. So the Azure SQL part of it is the cloud component, is the Microsoft offering in Azure, how you can actually deploy it. And it's a platform as a service where we own the patching, we own the maintenance, we own all of that. You don't need to worry about any of those. You just need to bring your code and use the database for that. So that's the main difference between them. And then if you go to the videos section, say this one, the more videos from our team, there's a I think a lot of great videos on the difference on different things that I showed in the first few slides. Okay, next question. How does Microsoft SQL Azure Server Hyperscalability storage that deployment infringed with the implementation of data storage? I don't understand the question fully. If you're talking about the storage, how Hyperscale does. So basically, as I showed in one of the slides, it's basic. It's segregation of compute and storage, and you can actually, in theory, have as many replicas for your data as for your compute side, and you can actually use this storage on the back end. On the back end, the way we do is we have storage components, and we also have many copies of that as well. So that's the feature set on that. Okay, so the last question, and if I'm not able to get to your question, please follow up. I will connect with me, and I will be happy to get into more details. So I'll take the last question here, which is, what is the processing time on Ledger feature? Yes, so there is a little bit of overhead. We have a published SLA, some of the numbers already. It's not super bad or anything like that. It's a few additional milliseconds or microseconds in some cases, and then you can definitely look that up. I'll find that link and probably put that as the material that I send out for you to read on. If you go to the Ledger overview page in Microsoft documentation, you should be able to get to that as well. So I think those are all the questions that I see in the Q&A feature. I think I went through everything in the chat as well. Thank you again for being here, depending on day, night, or evening, whatever it is for you. I hope you learned something new here. Then you're able to actually go and deploy certain apps. This is my link, LinkedIn and Twitter. You're free to connect with me afterwards as well. Ask any questions that I'm not able to get to. And looking forward to see what you go and develop with Azure SQL. Thank you so much. Thank you for hosting me.
Thanks a lot, Muazma Zahid. On behalf of Analytics Vidhya, I would like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future. And guys, if you have any more queries, please connect with Muazma Zahid in LinkedIn, and you can find her profile link in the chat box. and all other social media platforms too. I hope you guys have filled in the feedback poll. If not, I request you to please fill in the poll about feedback, as it helps us to conduct more such sessions. And if you have any queries, please feel free to connect with us. You can find all the emails and links in the chat box. And the recording of the session will be available in a few days on our YouTube channel. And that's it, guys. Thank you for coming here. We will be back with another session of DataHour tomorrow. The link is in the chat section. Till then, bye-bye and keep learning.
Thank you. Bye.
Yeah.